As our outback camps, our onboard electrical systems and our devices for a touring setup become more sophisticated and power hungry, creating and maintaining an electrical system off-grid has become a popular topic. Now, I've spoken about these power stations before, sometimes referred to as solar generators. This one here being one of my favorites, the Bluetti EB55. However, what we do know is that these don't generate power and they do require an external input, such as these solar panels, to keep us charged. Not saying they don't have a place in the off-grid setup or a camping scenario, it just might not be suitable for all situations. Now, I've also used and tested the Honda EU22 inverter generator on my last Jayco Journey caravan. Now, this generator is great. It produces reliable, efficient and clean power output. It powered all of the appliances in my previous caravan, most of them simultaneously. So what's not to like about it? Well, the huge size, the massive 25 kilo weight and the huge $2,100 price tag. Again, a great unit, but not suitable for all applications or budgets. So what's left then? Well, I went out to find the best value for money off-grid power solution. One that doesn't require the sun to be shining, won't push your vehicle over its GBM limits when hitting the tracks with your family, and most importantly, won't break the budget. This is the Gentrax 800 watt inverter generator, a compact, slimline and affordable generator on the Australian market. Containing a 40cc air-cooled 4-stroke engine alleged to run at 58 decibels and continuously for up to 6 hours with a 2.1 litre fuel tank. Claimed to come in at a very impressive 8.5 kilos, this generator sure looks the goods on paper. And that's just it, it does look good on paper. So I've been using, abusing, testing and monitoring this little generator for the last couple of months to see how it performs, put it through its paces and to see what it's like in real world situations. In this video, we're going to be looking at the physical dimensions and attributes of this generator, along with my first impressions of the build quality and features. We're going to look at the ease of access for maintenance, the first startup procedures, and of course, test this unit. We're going to be thoroughly testing the rated power outputs, the overload capacities, the AC power quality and wave formation, the noise levels, and of course those quoted runtimes. Finally, we'll finish up with some of the negatives, or at least the points to consider if you're looking at a unit like this for your setup. So without further ado, let's get straight into today's video. So when researching for a cheap alternative to some of the name brand generators like Hondas and Yamahas, I did notice something interesting. This Gentrax unit here comes in an 800, 1200 and 2000 watt variety. Nothing too surprising here. However, what I did notice is that this unit here appears to be the exact same specifications of numerous generators with the same physical attributes that are marketed across Australia and across the world. This generator can be purchased as a GS Moon, Dirty Hand Tools, Earthquake and BE Tools, and the list goes on and on. What became clear is that this unit is manufactured in the same factory in China and then distributed all around the world to brands who wish to stick their logo on the side and then market the product. I mean, look at this example here. We have Clark Power in the UK selling this unit and they haven't even been bothered to take a photo of it, rather just photoshopping their logo on the side for the website image. Regardless of the brands stuck on the side, in today's video, we're going to be testing out this Gentrax 800 watt generator, which I purchased from Outback's Camping in New South Wales. I personally purchased the unit off their eBay store for $279, delivered on a special price. Now I'll make sure to stick a link in the description below if you're impressed enough after this review and want to pick one up for yourself. So let's start with the physical specifications of this generator. The unit comes in at 395mm long, 209mm wide and 355mm tall. The official specifications claim a dry weight of 8.5 kilos, but realistically, we need to know the weight for ready to run. With oil and a full tank of fuel, I weighed in at 10.9 kilos. On the front leading side, we have a plain plastic cover displaying the Gentrax logo. Moving to the back side of the unit, we have a plastic grille design to allow the airflow from the exhaust. A round cutout from the exhaust is also present, containing a small metal gauze spark arrestor. On the far side panel, we have some of the controls, including the fuel priming bulb, the choke, the pull starter and the fuel valve. On the front panel, we have the bulk of the controls, the LED indicator lights, 240 volt and 12 volt outputs and ground plug. The two switches on the top of the control panel control the on-off function of the engine and the economy select, which we'll get into a little later in the video. We have 3 LED lights, a green indicator that shows us the inverter is working correctly, the red overload LED which will illuminate when the inverter cannot provide enough power required for the device, and lastly a red LED in case of a low oil level. To the right of these we have a single 240 volt outlet with a spring dust cover. I should note that this outlet is a standard 15 amp outlet, so not only will you be able to plug in any generic household appliances, but this will also accept heavy duty 15 amp leads, generally found associated with RV and caravan applications. We also note a small 12 volt DC outlet rated to 4 amp and a DC protection switch to the left. Under this we find our ground point should this be required for your application. On top of the unit we have various warning and instruction stickers, a small access cover and the fuel filler cap. The fuel filler cap does have an open and closed valve control which can seal the fuel tank when not in use to prevent those fumes from filling your storage area. The unit comes with a few accessories included in the box as well, and these include the generator's operating instructions, the DC power cables, basic service tools, protective cover and a funnel. So what were my first impressions? Well, the generator seems to have the same features and specifications of some of the more upmarket and expensive generators. The switches and DC protection switch are covered in this protective plastic wrap which will assist with weatherproofing. All of the switches, the dust cap, the choke, fuel filler cap and valves all seem to work with no dramas and moved freely as they should. I did note that the plastic panels felt a little bit cheap, and the seam running down the middle of the unit was a noticeably cheaper design and quality when compared with something like the Honda EU22 generator. Although the generator does come with a bunch of accessories, one thing it does not come with is oil. The unit is not pre-filled when delivered, and you will have to buy some oil in addition to get started. Now the manufacturer does recommend a high quality SAE 10W30 or 15W40 grade oil, and in today's testing I'll be using Honda's premium 10W30 grade oil, the same I use in my Honda generator. So given that we'll have to add our own oil to get started, this brings us onto the maintenance schedules and the access to the generator's serviceable areas. Starting from the far side panel, simply removing 4 screws, and this large panel can be removed from the unit. Once removed, we can see several parts of the generator, including the fuel priming bulb, the choke assembly, the carburetor, the air filter panel, and the oil fill and drain point. The oil sump is accessed by simply unscrewing this plastic cap. You will notice oil residue in here upon delivery, and this is evidence of the oil used in quality control prior to leaving the factory. Simply adding oil into the sump until that level reaches the threads of the filler cap, which is approximately 250 milliliters for this unit. The oil cap does come with a dipstick attached and is measured by placing the cap into the thread but not screwing it into the sump, ensuring the level is correct, and we are ready to go. While this side is exposed, we can also see the air filter. The filter cover is removed by unscrewing the single screw in the center of the panel. The air filter consists of a single dry piece of foam that can be pulled from the unit and cleaned in warm soapy water if required. So let's remove the front facing panel and see what's behind there. This process is the same as the other side and requires the removal of 4 screws, 1 in each corner. This side does not contain any serviceable items, however we can see more of the components located here. Taking a closer look at the electrical wiring, we can see reasonable quality and care taken here to ensure that all the contacts are adequately insulated with heat shrink. The wiring feels solid and is secured by a tie which appears to be adequate. Finally, on top of the unit we have this small access panel, which is removed by undoing this single screw. This panel is designed to give us access to the generator's spark plug, so let's see how easy it is to remove this spark plug using only the tools provided with the unit. We start by removing the lead by simply pulling upwards to expose the plug. We can drop the tool over the plug and use a screwdriver to unscrew the tension. Once loosened, this can be finished by hand and removed, a very simple and easy process. Refitting the spark plug, and it's time to put the unit back together. One of the only potential issues I found with the quality of the build at this point were the plastic threads that we are screwing back into. All of these plastic panels are being secured by screws that are threaded into plastic threads. Although I experienced no issues, this could be an issue over a long-term period, and particularly if these screws are over tightened. Now that we have added the oil, it's time to fuel up and start the generator for the first time. When starting a small engine for the first time, it's a good idea to pull the pull start a few times slowly to allow a little oil throughout some of the mechanical components. Once this has been done, turn the fuel valve to the on position, press the priming bulb about 6 times or until firm, turn the fuel cap to the open position, the on-off switch to on, the economy mode off, choke on, and pull the starter. In my experience, this only took 3 pulls to get this generator running on first startup. Once the unit has been run for about 1 minute or until warm, we can then select the economy mode to reduce the RPM. So far the unit is looking quite good. The quality seems to be okay considering the price. It sure is a compact and lightweight unit, and it started up very easily, along with the fact that we have easy access to maintenance and services down the track. But now we're getting into the nitty-gritty of the review, and we're going to be testing this unit. We're going to be testing some of the power outputs, the overload capacities, the run times, and seeing if it can hold up to some of the loads that I'm going to be placing it under. Now, with small engines like the one you'd find inside this generator, it's generally not a great idea to run it at full RPM on a high load brand new. These engines do require a break-in period, and because of this I have run this engine for about 10 hours at different RPMs from idle to about 50% to progress that break-in period, but now we are ready for some hard testing. Now, this generator is marketed as an 800 watt generator, which is a little misleading as that refers to its peak power and not its continuous output power. Reading through the manufacturer's specifications, we can see that this generator is rated to run 700 watt continuously. So let's start by testing this. I'll be using this watt meter attached to the 240 volt cable to measure exactly what the power draw is on this lead. In order to ramp up the wattage on the unit, I'll be plugging in my Bluetti AC200 charger that draws about 500 watt. I can then add this variable orbital polisher to ramp up the power output until the unit cuts out from overload. The unit starts off well, and we can see that there is a flash of the overload LED as the unit triggers the AC charger. However, soon stabilizes and appears to be running just fine at that 500 watt mark. As we add the variable polisher, we can increase the power demands at increments. Now we're able to ramp up the power to about 750 watt before the unit cuts out due to overload. We'll restart the unit and we'll see if it can run continuously just below this mark. Now, I changed out the variable polisher for my Bluetti EB55 charger, which draws a little over 200 watt of power. Plugging this in, and we can see a draw of just under 740 watt, and the generator was able to run this without an issue for an extended period of time, albeit the overload LED flashing. I also want to test out that peak power level, which is claimed to be 800 watt. Now, I've plugged in my 500 watt charger and the variable polisher, which I ramped up to maximum very quickly. We see that watt draw peaked at a short period, and then the generator shuts down. The watt meter is able to measure and retain that peak power value, and going back into the information, we can see the generator managed to peak out at 948 watt. Now, during my testing, I did notice that the generator struggled to add high power appliances when a load or even a small load was already applied. I plugged in my 200 watt charger, and followed by my 500 watt charger, we can see and hear that the generator bogs down, overloads and shuts off. I reversed the load application by adding the 500 watt charger first and then the 200 watt, and this time the generator is able to start and run both appliances. So even though the combined power input of these chargers is the same, the generator struggled to activate that higher load when that smaller load was running, so just something to keep in mind. So from this test, what we did ascertain is that this generator can quite easily maintain that 700 watt power output. In fact, it did better than that in our testing. We also discovered that it had a peak power output of 948 watts, which exceeds its 800 watt claim specification. We can also see that if you're powering multiple loads, it's a good idea to put in the high loads first and then add your small loads at increments after that, rather than the reverse. So one of the often forgotten about specifications or qualities of these generators is the quality and reliability of the power being outputted from them. So those who've had experience with some electrical language may have heard the term pure sine wave or modified sine wave previously. And this refers to the way in which the AC or alternating current is outputted from a source. AC power is an electrical current that periodically reverses direction and changes magnitude continuously with time. This is opposed to DC current or direct current, which only flows in one direction. When we refer to inverters, these are electrical devices or circuitry that can transform DC, which is what something like this generator produces, into AC power, but not all inverters can do this equally. In the electrical world, the cleanest type of power is referred to as sine wave, and sine wave is a geometric wave formation that oscillates up and down over time. Now, in comparison to this, we also have a modified sine wave, which attempts to simulate that of a sine wave, however it does it much less efficiently. In addition to this, modified sine wave also has the propensity to damage sensitive electrical equipment, things like computers, processors, video and audio equipment. So why would we ever use a modified sine wave? And the simple answer is because it's cheap to produce. Now this 800 watt Gentrax generator is advertised to have pure sine wave technology, and we can test this today. Using an oscilloscope, we can hook up the power outputs from the AC plug and see whether or not, or see what type of sine wave formation we receive. Now please note, I do not recommend conducting these tests yourself at home unless you are experienced and know what you are doing. In today's testing, we are using and working with live 240 volt wires, which can cause injury or death if used incorrectly. As you can see here, I'm using a regular 240 volt extension cable, which has been cut to expose the live wires to points at which I can attach probes to measure the power output. To start off with a baseline reading, I'm going to measure the 240 volt AC power direct from my home power grid. So plugging this in and setting the oscilloscope, we can see a smooth power curve across the power output. This device is measuring in the power of 5 milliseconds, and this means that each of those grid squares represents 5 milliseconds of time. Taking a snapshot from 5 milliseconds, 1 millisecond, and 50 nanoseconds, we see a smooth sine wave curve indicating clean and reliable power. Now plugging this test cable into the Gentrax generator, and we can take the measurements from the oscilloscope. At 5 and 1 milliseconds and 50 nanoseconds, the power has also shown a very smooth and clean output. Now, albeit there are some very minor deviations or distortions at the peaks, this is still regarded as a very clean power output in any instance. Now, just to ensure this is the case when load is applied, I'm going to apply a 500 watt load to the generator and continue to measure this output. And again, at 5 and 2 milliseconds and 5 nanoseconds, we can still see that we retain a smooth and consistent waveform throughout the output. So in conclusion, we can see that this generator can and is producing a very clean and reliable power, which means we're going to be able to power all of our sensitive electronics and do it at the best possible efficiency. Now, along with power outputs and quality, another big consideration for a generator is the noise emitted from these small engines. Whether or not you're powering a house backup system or you're out camping in your RV or caravan, the noise emitted from these engines can be disruptive and is a big consideration. So today, we're going to be testing how this unit performs. And in order to do that, we're going to be using one of these decibel readers. So let's take this unit outside and see how we go. The industry standard for measuring the noise level from a generator is from a distance of 7 meters and what is referred to as free field conditions. This means that the generator is away from buildings and structures that may cause echo or reverberation. And this Gentrax generator is advertised at a quiet 58 decibels at 7 meters. So let's test this. I brought my generator outside here today, and we're going to measure this generator noise level and compare this against the Honda EU22i. Obviously this isn't a fair test given the difference in the engine sizes between the two units. However, it'll give you an idea as to how it compares with these larger, better quality units. Now, before starting these generators, the ambient noise level is taken at about 34 to 35 decibels. Now, I will note that both of these generators have been warmed up and are at operating temperature. So we're going to start by running the Gentrax unit on economy mode, and we can see that the decibel meter is picking up an average of 57 decibels. Moving across to the Honda unit, also running in economy mode, we see an average of 53 decibels. Let's get these units working to see just how noisy they get when under full load. The Gentrax is currently putting out 700 watt at the moment, and we can see that noise level jump all the way up to 68 decibels. In comparison, the Honda is powered up and running at almost 2000 watt, and we see a significant jump to 68 decibels here too. This test goes to show that once again, the Gentrax lived up to its expectations and came in at 57 decibels when measured at 7 meters on idle and economy mode. Now, it did jump up to 68 decibels at full load at 700 watt power output, but what we did note is that it's very comparable to the Honda EU22 at full load too, which means that if you're using this in a camping or RV situation, it's not going to be any more disruptive than anyone else running the larger units. The other test I want to conduct today is the alleged run times. Now, this small 700 watt generator only has a 2.1 litre fuel tank, and the manufacturer specified that they can run up to 6 hours at 50% load. So this is something that we can and will be testing today. In order to conduct this test, I'll simply be running several small appliances off the generator for an entire tank of fuel. We are able to measure this through the same watt meter we use to determine the power output. We fill the tank, allow the unit to warm up for 30 seconds, and give it the best chance by switching it over to economy mode. I can plug in the power cable which runs through to our accessories with the watt meter installed. As we start up, we can see the power delivered to the watt meter, and since we had reset the meter, at the time at the top indicates the total time the power has been running through the meter. When the generator runs out of fuel, the watt meter stops the clock and retains the information gathered. Now we can see the test started just a little under 320 watt for the first 15 or so minutes. However, I was able to swap out a device to get this to come up to almost exactly 350 watts, almost 50% of the load capacity. Further, we'll also be able to test the total power outputted by the generator over the length of this test. Ideally, we're looking to achieve about 2.1 kilowatts, which is 350 watt multiplied by 6 hours. In the end, we observed that the generator ran for a total period of 6 hours and 38 minutes and outputted a total of 2.319 kilowatts. This generator again has once outperformed the claimed specifications, running for 38 minutes longer than the manufacturer stated it would, and therefore we ended up with a higher total output power reading as well. I think it's fair to say that this generator checks out. It's met, if not exceeded, all of the specifications from the manufacturer, which is surprising because generally these cheap mass-produced items claim specifications that they can never realistically meet. This being said, there are some things that I did notice through my testing and some considerations you might want to take into account before purchasing one of these for your setup. Firstly, as mentioned earlier in the video, the general build quality does not match that of higher quality and more expensive units. Although nothing's failed, seized or broken in my testing, the overall feel and look of the unit definitely reflects that cheaper price. Continuing on with this theme, the lower quality products can also be seen in parts like the oil filler cap. The plastic cap and thread struggled from time to time to screw back into the metal threaded oil sump. Now, although I managed to return the cap each time without issue, a small mistake or a little too much pressure could easily cause damage to the threads and create an oil leak. Also, as mentioned earlier in the video, the plastic nuts that the screws supporting the panels screw into are a long-term concern. Again, I had no issues with these during my initial testing. However, I was also very careful not to strip the threads or over-tighten these screws. Constant removal of these parts or accidentally over-tightening the screw could very easily cause damage and therefore create issues fixing the panels onto the side of the unit. Now, one issue I did come across with my testing was a small fuel leak. One of the nights when I was doing my break-in periods with the unit, I filled a tank up to maximum and left the unit for about 24 hours. Upon coming back to the unit, I did notice it had leaked just a small amount of fuel from underneath the generator. So I took the side panels off, but I was unable to ascertain exactly where that leak came from. Now, I should note that I also observed that I left the fuel valve on the side of the unit to the on position. I again conducted a couple of tests with the fuel tank at a full level with both the fuel valve on and off in storage for a period of 24 hours. And I did notice when that fuel valve is left on, there is a small fuel leak from the internal hoses. When turned off, I experienced no leaks at all. Now, I should also note that if a fuel tank was at a half level and left even with the fuel valve on for a period of 24 hours, I didn't notice any leaks. So just a consideration, if you plan on leaving that fuel tank full, just make sure that fuel valve is switched off. Now, one of the points you need to consider if you are looking at a unit like this for your setup is the fact that it is not designed or manufactured to power high-powered appliances. Things like coffee machines, aircon units and heaters, induction cookers are not going to work off a unit like this. We also saw during our testing that high appliances or high-powered drawer appliances without soft start functions can also create issues on that startup. This is not necessarily a negative of this unit because it's not designed to power things like that. If you are looking at powering those high-powered devices like air conditionings and heaters, you may need to look at a bigger unit, perhaps something like the Honda EU22. In conclusion, I have been very impressed with this little unit. I'm not going to lie to say that I was skeptical when purchasing the unit, and I struggled to find some of the results of the tests that I've conducted today online. But I am happy to say that I was wrong. This little unit has performed flawlessly throughout all of its testing and has met or exceeded all of the specifications alleged by the manufacturer. Now, don't get me wrong, I know this is a cheap unit and I've spoken about some of the cheaper quality parts earlier on in this video. But the fact that I managed to pick this little unit up for $279 delivered to my door in regional Western Australia, the value is absolutely amazing. To put that into perspective, the Honda equivalent, or a small size Honda generator, the EU10i, has a power output of only 200 watt more at 900 watt. but it cost $1,599. So to put that into perspective, that means that even if this unit only lasts me, say, a couple of years, I could afford to buy almost 6 of these generators for the price of one Honda. Not to mention that this unit here is claimed to be 4.5 kilos lighter, according to the dry specifications, than that Honda unit. So why did I buy this unit? And the answer is simply because I wanted something that could power the batteries of our new van on the odd occasion. Now, a new caravan does come with a large lithium power bank and probably a little over the top solar capability. However, there are going to be times when we're camping in prolonged bad weather or perhaps camping under the canopy of large trees. And without external output or external input, there is a chance we could run out of power. Now, yes, I could be using my Honda EU22i generator. However, it's probably a little overkill for charging a couple of batteries, and coming out at 26 kilos, it's sure a much larger and heavier unit to charge a couple of batteries on the rare occasion. So the big question is now, will it last the test of time? Well, I've put about 25 hours on this small engine since owning it through all the testing and the braking periods, and so far it's performing quite well. Between now and leaving for our big lap around Australia in December, I'll be conducting several more tests and longevity tests to see whether or not this is going to be a viable unit to take away with us on our trip. If it is, and it does end up in our van for the year around Australia, I will make sure to follow up with a long-term review, performance, and any issues that arise during that time. So thank you very much for watching today's video, and I hope I was able to provide some useful information that can assist you to determine whether or not a unit like this is going to be right for your setup. Like mentioned at the start of the video, I will put some links in the description below to this unit and where I purchased it from. But guys, thank you very much, and we'll make sure to see you in the next episode. Cheers.